Hi, my name is Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. In this movie we're going to look at shared CPUs and in particular pool monitoring. We'll explain these two flags as we go along. In our Power 5 or Power 6 based machines, the CPUs can be doing one of three different things. Firstly, they could be unallocated. That means they're a capacity upgrade on demand type CPU. They're in the machine, not actually being used, can't actually be used until an activation key has been entered into the HMC. They then become available and they can dynamically be added to a running logical partition on the fly. The second use for our CPUs is for dedicated CPU logical partitions. Here we take the CPUs and allocate them to particular logical partitions and therefore the sole use of that logical partition. This feels safe and understandable. We've taken a large machine and broken it up into a number of smaller ones inside. There are a couple of things that we need to be aware of though. We can't borrow with a dedicated CPU partition CPU cycles from somebody else. If, for example, we have one CPU in a logical partition and we have a massive peak arriving we could really do with 3 or 4 CPUs for a few milliseconds, well, we can't. We've got one CPU and we'll just have to handle that peak the best way we can, and it will just take 3 or 4 times longer to actually handle that workload than necessary. The second issue we have is that if we're not using the CPUs, we can't loan them out to somebody else that desperately needs them. We might have 2 CPUs in a logical partition, but we're only using a quarter or a half of a CPU at most. The other 1.5 CPUs worth of power is just running idle loops. That's not effective use of our CPUs, and that's just wasting the money we spent on our CPUs. Fortunately, with Power 6 we have a feature called dedicated donating, so we can allocate CPUs to a dedicated CPU partition, but it will automatically then donate these unused compute cycles to the shared pool. The third use of our CPUs is from the shared CPU pool. So we create a logical partition using shared resources, and these are quite flexible. After the first tenth of a CPU, it's in 1/100th of a CPU. So for example, we could allocate a shared CPU logical partition 1.6 CPUs. And this sort of mode of working allows us to actually loan CPU cycles to other logical partitions using the pool. This takes less than a millisecond, so as soon as we don't actually need the CPU, we would go into an idle loop, we actually yield the processor so somebody else could use it. We can also borrow CPU cycles. If we need more than our allotted 1.6 CPUs, we can borrow CPUs from other logical partitions that aren't using those. And with 1.6 we could actually peak to 16 CPUs temporarily, use all that compute power to get through our peaks. Then we can release those CPUs and somebody else going through a peak can actually make use of a much bigger number of CPUs temporarily. There is a slight downside. There is a slight impact on response times, and we're talking very small here, fractions of a percent. And compared to the wasting 1s and 2s of CPUs that we can get with dedicated partitions, this is extremely small impact. And it's cost effective and it gives us high performance. Also note that in Power 6 we have what's called multiple shared pools, and we can use this feature for example controlling license costs. Now from the above argument I hope you understand that I'm a big fan of shared CPU logical partitions. With the dedicated CPU logical partitions we typically go and monitor the utilization of the resources allocated to those logical partitions. But with shared CPU logical partitions we have to monitor 2 different things. The utilization numbers don't help us very much. First of all, with each shared CPU partition we have to monitor how much CPU time it is actually consuming. This is more important than the utilization numbers, because whenever we would have gone into an idle loop we now actually yield the processor, so that makes the utilization numbers a little confusing to say the least, and we won't cover that in any more detail here. The other thing we need to monitor is how much of the CPUs in the pool is actually not being used. That, if you like, is the opportunity we have. We can either allocate more of that CPU time to particular logical partitions, Or we may decide we have enough CPU power in this machine to actually add a few more logical partitions without actually having to buy a larger box. Now, from the above argument, I hope you understand that I'm a big fan of shared CPU logical partitions. With the dedicated CPU logical partitions, we typically go and monitor the utilization of the resources allocated to those logical partitions. But with shared CPU logical partitions, we have to monitor two different things. The utilization numbers don't help us very much. First of all, with each shared CPU partition, we have to monitor how much CPU time it is actually consuming. This is more important than the utilization numbers, because whenever we would have gone into an idle loop, we now actually yield the processor. So that makes the utilization numbers a little confusing, to say the least. And we won't cover that in any more detail here. The other thing we need to monitor is how much of the CPUs in the pool is actually not being used. That, if you like, is the opportunity we have. We can either allocate more of that CPU time to particular logical partitions, or we may decide we have enough CPU power in this machine to actually add a few more logical partitions without actually having to buy a larger box. So let's investigate monitoring our shared CPUs, and in particular the shared CPU pool. I have two windows here onto two logical partitions. They're on the same machine. It happens to be a Power 6 based machine, and I have a HMC7 connected to them to control them. In this one, this is a P05 logical partition. I'm going to run our lparstat command, a very good way of understanding what's going on in your logical partition. We're a shared and uncapped, and our entitlement is here at 0.2 of a CPU. Now it's very interesting to note that as you come over your entitlement, your utilization, which is the user and system number, will get to about 99%, and as you go over your entitlement, it will go from 99% to very nearly 100% used. And this means that our utilization numbers don't make an awful lot of sense with shared CPUs, because we'll get to 99% as we go to an entitlement, and then from 99 to 100% as we actually go up to 10 times faster if we've got enough virtual processors. So we entitled to 0.2%. You can see here this is a much more sensible number. Our physical consumed, we're actually consuming 0.8 of a CPU. Nice and steady. This is actually a generated workload, so it's nice and steady. And we can see that that is 4 times our entitlement. Our percentage of entitlement is 400. But this administrator can't see the shared processor pool. Are we being limited to this amount of performance because the pool is actually empty, or is there spare CPUs that we could use? Perhaps we could change the way we're operating here, maybe start more processes, more threads, or more jobs, and to use those extra CPUs. Are they free or not? Well, if you go to this logical partition and run the same command, we'll see here's shared and uncapped 2. He's entitled to half a CPU, but he has an extra column in his output here, APP, which is available physical processors in the shared pool. So these are the free CPUs in the pool. And we can see that's fluctuating. That's between 0.7 to 1.7, roughly speaking, up and down. So this systems administrator knows that there's free CPUs in the pool up for grabs, but this one over here doesn't. There's a good reason for that, and I want to flip over to the HMC to tell you how to switch that on and rectify that situation. Here's our two logical partitions, P10 and P5. And we're going to change something to do with this P5 logical partition. Now I've already selected it here. I can either hit the properties, or I can just actually select the name of this logical partition, or I can go in here and select properties. We end up at the same panel whatever we do. This is our hardware management console 7, HMC 7, which can control Power 5 or Power 6 based machines. And a nice feature here is this is reminding me that this is AIX 5.3 maintenance level, or TL6 service pack 5, which is a nice feature, but that's sort of by the way. If we look at the hardware, we have the processor's memory and I/O, and we have some of the details that we saw on the screen, and we have a flag here that is unchecked. We have Allow Performance Information Collection. Now, if we were on a Power 5 base machine and a HMC6, that same flag would be called Shared Processor Pool Utilization Authority. A bit of a mouthful, and I think it's an improvement on what it actually means, because it's not a utilization of the CPU, it's how many CPUs are free or not used at the moment. So let's fix that. We'll select that, we'll OK that. I'll take a second to take. And if we come back to a machine here, the first encounter of that new variable is here, so we'll have to ignore that. And we can see we've got an extra column has appeared, and if we get down to the bottom of a page here, it will tell us that this new column is the APP, the available physical processors, or what's in the pool, not being used. There we go. So we have the APP column here, and we can understand now what's going on. There is free CPU not used in this machine. We could either use that CPU power to run another logical partition, or we could do some tuning with our applications to go and use that spare CPU power as it's up for grabs. Now in this case, this APP column appeared immediately. If we are on a Power 5 base machine, particularly if we had old firmware, that wouldn't take immediately. We have to do a hard stop of the logical partition, by which I mean we don't do a shutdown minus FR or a restart of that logical partition. We actually have to stop the partition completely and then restart it to actually pick up that new environmental variable, so that we actually now have this column available to us. So just a quick reminder there that if we want to monitor our shared pool, then we have to, at the logical partition level, switch on the flag that is either called in Power 5 and HMC6 Shared Processor Pool Utilization Authority, or if you've got a HMC7 and you're on a Power 6 machine, then it's called Allow Performance Information Collection. A couple of words about security. I switched off the allowing the performance information collection again, so you can see the APP line, the column has gone missing in LPAR start output. I'll just stop that. I'll run Topaz minus capital C. This is what's known as the KEK view, so this will give us a summary of all the AIX partitions on the box, and will allow us to have a look at the overall performance of the machine. And the reason I'm doing that is that we actually have this available physical processors in the shared pool value up here. So even though access to this is switched off, we can actually get this still with the Topaz command. Now it does take a while to start up. There we go. So these are the host names here. You'll notice these aren't the logical partition names, and we have the APP value up here. And we can see that we're using physical CPU in here. P10 is using the 2 CPUs, and P5 is using 0.8 for CPU, as we watched it the other time. And this number will go up and down as different workloads run. Now it may not be obvious, but the Topaz KEK monitor here isn't getting this information out of the hypervisor or out of the core of the machine. What it's actually doing is using RMC to work out where the HMC is. It's then talking to the hardware management console to find out about the other logical partitions in this machine, and then it's going to the daemons running in those copies of AIX to pull out this information. And the Topaz here, if any of the logical partitions has the available physical processor numbers here, it can fetch that out and display them on the screen. You still might be wondering why there's a slight security issue in here. Well, if you imagine somebody in one logical partition could be using a workload to signal via the amount of spare CPUs there are in the pool. They could suddenly get busy and suddenly get quiet in the logical partition, and the pool will get bigger and smaller, and you could use that as a signaling mechanism. Somewhat unlikely, somewhat slow, and because logical partitions are coming and going in their workloads, actually a very noisy covert channel between two logical partitions. But if you're worried at that sort of level of security, you actually have very secure information in one logical partition and insecure access to another logical partition. You will have to make lots of other security mechanisms inside your machine. For example, you must not be able to allow you to communicate between your logical partitions. As you can see here, Topaz is using the network to get to all the various daemons running on all the logical partitions. So you'd have to VLAN out or use a switch to stop the LPARs from communicating. Now, in my experience, I've never met a customer operating at that very, very high level of security where they worry about pool monitoring. I wanted to make you aware of the issue and the fact that you can switch that off if you really need to, but I do highlight the fact that you'd have to do extreme things with your network as well to stop every possible other means of getting data off an awful lot faster than you could with this covert channel via the pool monitoring. This pool monitoring could operate at something like 5 or 6 bytes a minute. Well, I hope this movie's encouraged you to think very seriously about using shared CPUs out of the shared pool, and that we remember we need to monitor the physical CPU use in our shared CPU logical partitions. Don't look at the utilization because that can get very confusing. And we also need to monitor what's available in the shared CPU pool.